Evet. Hello everyone, welcome to Gamze Technical University Bioengineering Department webinar series. Today our guest is Dr. Gamze Müjdeci. I would like to briefly introduce her. Gamze Müjdeci is a research assistant at Hitit University. She completed her Bachelor of Science and Master of Science at Food Engineering Department at Hacettepe University. And her PhD was completed at 2019 at Food Engineering and at Hacettepe University. And now, dear doctor, stage is yours.
Thank you for this nice introduction, dear Buse, and I want to thank also Professor Uguntala and his colleagues for inviting me to this webinar series. Good afternoon, everyone. As you can see on the screen, my presentation topic is Bioengineering Perspectives, the New Frontiers for Food Biotechnology.
Sorry, we couldn't see your screen actually now. Maybe you can
let me share again. Okay, I will do that. Do you see now?
Yes, we see now. Thank you so much.
Okay, you're welcome.
Please activate your microphone. Okay.
Do you hear me now? Okay.
Yes, thank you.
Okay, then I will continue. Before my talk, I'm planning to start with the scientific interest of today's bioengineering.
Sorry for interruption, but again, your microphone is not active.
But I open my microphone, but I don't know what is happening.
We hear you. Okay.
Okay. Then I will talk again. Before my talking, I want to give a brief outline about my presentation. I'm planning to start with the scientific interest of today's bioengineering, and then I will give a definition of food biotechnology. I'm continue with the fermentation process and the focus on the products of this industry. And then I will continue with the challenges in the fermentation process and their solutions. And I am gonna give a brief information about my current projects. And finally, I want to talk about the future trends in food biotechnology. Then I will be ready for answering your questions. And as you all know well, the bioengineering discipline includes many scientific interests, and these are bioinstrumentation, bioinformatics, biomechanics, or biotechnology, and pharmaceutical engineers, and so on. And among them, the biomaterials and biotechnology, and also bioprocess engineering is really related with the food biotechnology industry. And before talking about the food biotechnology, I want to give the description of biotechnology. This discipline is defined as the use of living organisms to make useful products. And in food biotechnology is the application of biotechnological techniques to produce the food products as well as the ingredients and the food additives. And fermentation process is the oldest and the major process that is used in food biotechnology industry. As you can see on the timeline, fermentation dates back to the ancient times with wine making and also cheese making, and even before the exploring the microorganisms. In 17th century, von Leeuwenhoek, who is the father of the microbiology, observed the yeast cells in alcohol fermentation. And in 18th century, pressed bakeries was produced by Dutch, and this was the first improved process. And in 19th century, two of the important sciencemen played a key role in the fermentation process. The one is the Pasteur demonstrated the living yeast cells in ferment sugar into ethanol and carbon dioxide, and the other was the Koch developed techniques for the handling and maintenance of the cultures. And this was the first modern industrial microbiology technique. And in 20th century, biorefinery approach started to be used, and the molasses was used. And today, the precision fermentation is really important and becoming popular. And meat analogs have been started to be produced through the fermentation. Yes. What are the products of the fermentation industry? The oldest and the common product is actually fermented foods and beverages. They are produced through the traditional fermentation. And for industrial scale fermentation, the starter culture development is also very crucial and beneficial for standardization. So researchers are trying to isolate microorganisms during the processes, and then they identify them by using the biochemical and molecular methods, and then the microorganisms are tested according to their technological characteristics. And the other product is probiotics. These are actually exist in our natural intestinal flora. But due to the environmental factors, their numbers are decreasing. So it's essential to eat them inside the food or directly. And they are produced by biomass fermentation in industrial scale. And the other product is biomaterials. These are actually used in several industrial areas, including the textile and pharmaceutical, chemical, cosmetic, and so on. In food industry, they are used as microbial food ingredients. They can be organic acids, aromas, flavor enhancers, pigments, stabilizers, thickeners, and preservatives, and so on. And the enzymes are one of the most important products of the fermentation process and needs really special professional skills. And these products are also have very huge application area, but in food industry they are used in bakery or dairy product production or fruit juice production. And the food safety is another issue in food technology. Biopolymers produced by the fermentation can be used as a coating material with the plastic packages or instead of plastic packages and with the antimicrobial agents. So these kind of packages are called as an active packing and increase the food safety. And this process is also becoming common today, and it seems to be in the future. And what are the challenges what are the challenges in the fermentation process? The most important challenge is actually the cost. And also the maintaining the desired optimum conditions and impurities during the process is another two challenges. And what are the solutions? The first solution is the biorefinery concept. First of all, I want to give a define of this concept. This is the sustainable processing of biomass into a spectrum of bio-based products and bioenergy sources. So for fermentation process, biorefinery concept or approach is using food waste or agricultural waste or the byproducts of food industry as a substrate in the fermentation media. So these waste and byproducts become a valuable raw product instead of being a waste. And also this process by using these materials as a substrate also protect the environment and also decrease the cost of the fermentation process. Another solution is the optimization. Optimization is a process improve the yield and decrease the process cost. In that step, the main idea is determining the most effective or most important parameters that affecting the dependent variable. The dependent variable in this case is maybe the yield or of the fermentation or the concentration of the product, and depends on what you want to optimize. And for that, the response surface methodology and central composite rotatable design or central composite design are really common statistical techniques to be used. And if we think about, there are many parameters affecting the fermentation process. These are temperature, pH, or agitation rate, time of the fermentation, concentration of carbon or nitrogen sources, and so on. So the optimization is really crucial also for improving the yield and decreasing the energy costs and other costs. And one other design is the downstream process design. The downstream process is collecting the product from the fermenter or from the media, and for pure product production and for the high yield, this design is also very important and depends on the substrate you use as in the fermentation media, and also product you will produce on fermentation conditions, it is submerged or the solid state. And also fermentation scale is really important at that point. And there are many methods to be used for separation the product from the fermentation media you can see on the screen. These are centrifugation and water absorption or ion exchange and several filtration methods. And these methods can be used separately or with the combination, and also with the complementary methods as expanded bath absorption chromatography. Last solution may be the purification fermentation. This fermentation technique is not new, but becoming popular today. And actually, in that kind of fermentation, genetically engineered microorganisms are used, and the target is only one kind of product in the media, and almost there is no impurity in the media. So really important to increase the yield and decrease the impurities. And also, this is a multidisciplinary way of the fermentation. So the artificial intelligence, bioinformatics, system biology, or computational biology disciplines are also needed in that kind of fermentation. After all these informations, I want to give information about my research project. Actually, my projects are also basically about the valorization of waste, food waste, or industrial byproducts to produce high value added products that can be used in disease treatment or in food packing or cosmetics, and depends on the product. And in that project, this is the TÜBİTAK project that I am in. I am a principal investigator in that, and we try to use several food waste. These were carrot peel, potato, melon, and watermelon peels, and also byproducts. Whey is the byproduct of dairy industry, cheese industry, and also molasses. This is the byproduct of sugar industry. And by using them as a substrate, we produce the melanin. This is a pigment, black pigment, through the fermentation. And After the process optimization, we purify and characterize the melanin, and now we are trying to test them on their toxicity on adenocarcinoma cells, the lung cancer cells, and also healthy lung cells. And we are obtaining the results now. Another project is also TikTok project. This is the main project. We haven't started the test yet, but I am a researcher in that project, and I am responsible with the biotechnology side of that project, and my colleague is responsible with the food safety side. We are planning to produce quercetin from skin of the onion, and also at the same time we will produce the pluvan. This is a biopolymer through the bioreactor fermentation. Quercetin is antioxidant material and became popular during the COVID pandemic. Maybe you have heard about it. And pluvan is, as I said before, this is a biopolymer and is used in several industrial areas, including the food industry, but not in Turkey. After optimization and purification steps, we will use two of these materials in edible film packing system. Pluvan will be used as a main package material because of its excellent film formation property, and quercetin will be used as an antifungal agent. And we will coat both fresh figs and the dry figs, and then we are planning to extend the shelf life of fresh figs and mycotoxin formation and preventing the mycotoxin formation in dry figs. This project is important because we are the leader fig export in Turkey. I mean, the Turkey in world. Turkey is the big fig exporter in the world, and also producers. So we are collaborating with the exporter company in Turkey. So maybe later I will share its results also with you. And the last project is also about valorization of food waste, bread waste, and my students use the bread waste to produce the pluvan, and we collaborate with the Bahçıvan food cheeses, and we use this coating material as an inner coat and under the plastic package instead of the modified atmosphere. And the results were promising, and we will continue the project, and we will try as a pilot scale or maybe later in industry scale. Now I want to continue with the future of the food biotechnology sector. And it seems that active and intelligent pattern, biomaterial production, and enzyme and functional food and beverage production will keep their popularity in the future. But what is the new? The new one is the food analogs. Food analogs mean the food substitutes, and the people try to produce these substitutes because of the limitation of food sources. So in the future, we will see more commonly the food analogs in the supermarkets, I think. And now there are some samples in United States. One of the, or more than one, startups producing meat analogs. And meat analogs can be produced by using the plants and also through the fermentation. But in my opinion, using plant is not sustainable because producing a substitute by using another food source is not sensible according to me. But the fermentation step will be the crucial in that process also. So for more details, I wanna show you a video that that explain how the meat analogs are produced, and then I will be ready for answering your question.
Sorry, but we didn't hear the voice of the video.
You don't hear the voice?
Yes.
Hmm.
You should allow the voice via Teams actually for computer.
Okay, I will try. I will try. For that next. How should I do that? I don't know really.
Muhtemelen Türkçe yazıyor, o yüzden Türkçe söylüyorum. İçeriği paylaş derken o içeriği paylaşın sağ kısmında bilgisayarın sesini ekleyin yazıyor. Onu aktifleştirmeniz gerekiyor.
Okay. Tamam. Şu an duyuluyor mu?
In the foothills of South San Francisco, perched above a Silicon Valley freeway, is a test lab designed to hatch in the foothills of South San Francisco, perched above a Silicon Valley freeway, is a test lab designed to hatch a new kind of egg farm. No cages, no conveyor belts, and crucially, no chickens.
We produce real animal protein without using an animal. It is identical to what the animal makes.
The Every company is refining its production of animal-free egg white and protein. Backed by $233 million in funding from as far afield as Singapore, it uses different technologies, genetic engineering, and the age-old process of fermentation.
So in the same way that brewers use yeast to convert sugar into alcohol to make beer and wine, we use yeast to convert sugar into protein. But what we do specifically is we can 3D print the DNA sequence that codes for any protein known to man and feed that to the yeast. And so as the yeast eats sugar, it starts actually reading the DNA sequence and then starts printing out the specific protein that it was encoded.
Fermented protein is a budding industry within the alternative meat sector that's found a home and plenty of capital in and around San Francisco.
People here are willing to fund crazy ideas. You have a huge critical mass of people who made their money, being very early stage employees at some of the biggest tech companies in the world who had crazy ideas as well.
Using fungus to make bacon and America's beloved deli meats like salami and turkey might seem like a crazy idea too. But it makes perfect sense to investors who've stumped up at least $18.5 million to fund another local startup, Prime Roots, to do just that.
Hi,
I'm
nice
Dave.
to meet you.
Great to meet you.
Americans on average eat 200 deli sandwiches per person per year. And so it really is this everyday staple. Within conventional deli meats, there's a ton of baggage. So, you have nitrates, there's a lot of hormones, antibiotics, salt, the list goes on and on. Our ingredient list is really short and clean, and that's something we take a lot of pride in.
I'm invited into the test kitchen where deli meats like are made without meat.
This is where we make the magic happen.
Right. The protein comes from koji, a fungus with mesh-like filaments or mycelium. Such fibers from other kinds of fungi are also used in corn and other meat alternatives.
This is some koji we grew in a ball jar, but it really lets you see the fibrous texture that the koji has. It really replicates the microscopic texture of the meat.
Once the sugary fermented liquid has been drained,
A little bit. Start the mixer.
the koji can be mixed, seasoned, pressed and baked into all kinds of forms and flavors.
Watch how nicely it slices.
I'm sampling a slice or three of koji fungus salami. It's not just acceptable salami, it's good salami. It's delicious. Tasty as alternative protein be, the industry faces an uphill battle in convincing consumers to make the switch. Here in the US, conventionally reared animal proteins still dominate the market. The value of the global meat market was estimated at up to $1.8 trillion in 2021, dwarfing the $9.9 billion valuation of the meat substitute sector. But that's expected to change. In the US, per capita revenue in the substitute market is projected to almost double in 5 years, from $3.90 in 2021 to $7.27 by 2026. Journalist and author Larissa Zimberoff has documented the fusion of food, technology and business, especially around her hometown.
That it has to be more delicious.
And is an expert on alternative proteins.
So you're going to try the plant-based lamb today.
I'm going to give it a go.
She believes younger generations and increasing concern over the emissions and environmental damage from livestock industries will drive high demand for alternative, more sustainable meat substitutes.
Plant-based meats only has about less than 1% of the meat sector, right? And they have a huge way to go. But once Generation Z and Generation Alpha pick up, and once they have control,
But I want to know how fermented protein makers can compete with the producer of the vegan lamb in our salad and established plant-based brands selling burgers and nuggets in supermarkets and restaurants across the country.
fermentation is one of the top dogs right now. People want to call it clean. It is a short ingredient list, and you can wrap your head around it. Unlike the plant-based alternatives, which have, 12 to 15 ingredients.
But the biggest advantage for fermentation may be cost. Cultivated or lab-grown meat makers are struggling to upscale production to make their outputs viable and agreeable to food regulators. Most plant-based protein contains pulses and grains, many of which have soared in price and often requires sophisticated and expensive equipment to make it look and feel like meat. Neither of those issues apply with a fermented protein that can be grown in a basic sugar solution and formed using conventional catering kit.
Our timelines and our costs are less expensive than if you had to custom make equipment. In terms of the cost, right out of the gate, we're actually pricing competitively with the middle of the market.
For animal-free egg white manufacturer Every, the trick is to partner with established companies like brewing giant AB InBev and use their existing facilities to ferment the protein.
So there are companies around the world who have fermentation facilities where we can immediately plug and play into, and that have maximal optionality and scale up very, very quickly.
Conventionally reared meat is still popular in the alternative-friendly streets of San Francisco. But California is also one of many regions bearing the brunt of a changing climate that brings high-emission industries like conventional agriculture into question, and emerging sectors like fermented protein into the spotlight.
Yes, thank you so much for listening to me. I'm ready for your questions.
Thank you for your excellent presentation. Dear participants, if there is any question, please ask right now. Is there any question? I suppose that there is no question.
Okay. Thank you for your attendance. It is very nice talk. We
Thank
can
you.
stop recording, Buse.
Okay. Okay.
Then let's turn to Turkish. Hoş geldiniz hocam.
Merhaba, hoş bulduk hocam.